The first thing I want to do is finish this problem here. Of course. This will also give me time to think about exactly what I'm going to do next. And then after this we can debug to see if we've missed anything. Which, because of this setup, is going to be very easy. And then we just need... Actually, we need a monostable here. And that attaches to this portion. And then finally these wires. And now I can blanket the entire memory bank to see if I've missed anything. Actually, it's going to be very hard to see. I can just inspect closely, it should be fine. That one works. Actually, the hardest part of this is manually counting in binary. There's a reason binary is not the number system people use on a daily basis. That's because it's too simple, which is a problem much like the problem the Roman numerals or tally marks have. Very primitive and barbaric. And then you also have problems having too many symbols. Hexadecimal is the largest base number numeric system that I would settle with. It looks like everything is correct. And that's as exhaustive of a test as I'm willing to perform right now. So this should be one complete cell, or technically it's a bank, but it's going to be in a bank, so it's a sub-bank, I should say. There. So now all we need is the serial addressing system that clamps onto each one of these sub-banks, and then we can start building out our string of memory modules here, as is shown in the diagram. And so, if the address is outside of the scope of the first one, it will immediately reroute the addressing and memory to the next one. And so it will be like some kind of a decentralized network, a peer-to-peer network, where the peers are actually handling the routing. And so it's similar to neurons in our brain, actually. This multi-core situation I don't think is a good idea to start with. And the state machine, recently realizing there's a lot more about it that I need to figure out before it's even workable. And the I/O handler is going to be interesting to figure out. So I feel like we may actually need more than 16 states. Either that or hold the state separately in memory, in possibly the boot sector. Have that be where the simple operating system works. What if, instead of having the entire setup be on the hardware, I make the hardware as simple as possible, and then have the way the computer works encoded in memory in the boot sector as the operating system, and so focusing much more on software than hardware in order to simplify the hardware. The only downside to this is the software can get complicated fast. I'm also thinking about having the program counter, instead of being in the control unit, also be somewhere in the boot sector. Which is going to be this first memory module, and if the system gets too complicated, it's going to need to be able to extend to the next modules. I can't do entirely speculation right now, though. This is something that needs to get done, actually. And so... trying to think of exactly how this should go on. Technically, it's a separate module from the accumulator itself, and so it should probably itself be kept separate. Physically. And then in this gap, we might need to have a method for dealing with this. Yeah, perhaps something like this. And then I'm also going to need to fill this out. Put a bed under it so that it's not just overhanging, which is irritating. There. And so now... Or... yeah, this is going to be a mess, I can already tell. So the new idea is to have, because this is already a stack, moving this in that way, but it also needs to move forwards and backwards. So it's going to need to be a 4-dimensional matrix shifter. I mean, 2-dimensional, not 4-dimensional. That would be ridiculous. And so this should be going that way, and the other one should be going the opposite way. And these also need to connect to all of these. All of these. Now that's going to be a nightmare. In fact, I may wish to first remove this, and then do all of that with different pins, and then put it back on. And just roughly estimate how long that was. There. Also remove these because I'm just going to route them from those pins. And so now, I think a good spot for this would be here. Should also put a plate on it, like I did with the clock. There. And now the components. Which would go here. And this will be to green. And this one will be to the other one. And now the fun begins. It's just like the memory. This is the problem of showing the entire process, instead of just showing the best parts of it. So this is going to be the first bit in the 4-bit line, parallel. Needing to do it 8 times because this is 8 entries deep. Yeah, 8 per bit, that is. And so that would in total be, I think, 32. And that's only for one of these 2 pins, and so that's 64 together. Now to test. I always hate the necessity of monostables. This appears to be functioning. So that's going to be an ongoing project. And of course, since that's such a large project now, and I'm not going to be able to complete the ALU until I finish that, going to need to delay the ALU as well now. And so we have time to finish working on the bank of memory. Technically not done because the output selector isn't even attached yet. Oh yeah, that reminds me, I need to figure out a better way of doing this. Or perhaps this is the best way. It couldn't possibly be though, could it? Now this is why memory is always a nightmare to do by hand. Especially any amount of memory that's worth talking about. Doing memory with single bits is simple, but doing memory with half bytes, or even worse, whole bytes, like before, I remember spending days working on that one RAM cell that was 64 entries. RAM bank, I mean. And here is when I run into the roadblock of not knowing what exactly to do next, which is always the problem. The primary problem. And because of how script mechanic works, a main bus can just be one row of logic, and they must all be OR gates as well. So this is our main bus here. I'm just going to set that down. We could just spend more time wiring this, but then that's not even good. I'm going to do 2 more right now. Technically 4 if you count them separately. Wow, everything requires massive wiring right now. You see, this is why big projects are hard. Not because it's actually difficult to formulate the concept, but because the wiring is a nightmare. Now what? The state machine could use help. Trying to think. This is going to be the worst episode yet, I can already tell. Where's the branching? The comparison operator I was thinking about. And so... instead of any of these, I'm going to use... this. And the first argument it's going to take is this. And the second is going to be the next one down in the stack. This is going to be our comparison operator right here. The XOR gates will detect if there's any difference between the bits. And then if there's any difference, this will activate. So that's going to be our equal operator. What about less than and greater than? Oh yes, now I remember. Usually in order to do those, you would do math. This seems like it may not actually be a great idea, in second thought. I'm probably going to need to take a break from doing all of this for a while, since getting quite daunting, as you can see here. Actually, I do know one thing I could probably do. So first I'm going to save this, but not before checking what it is exactly. Yes, the board is necessary. So what I can do with this is first I'm going to make a copy. And now I'm going to clamp it onto the screen. Do I save the screen? No. I wonder why not. And I'm going to put a board under this as well. There. So first I'm going to save this, and then I'm going to start attaching the screen space memory. Or, is that a bad idea? No, it should be fine. Trying to remember 4x8. And quaternary screen. There. And that's not enough room. And that's not the right material. Hmm. There are many cases in which having too much room is better than not having enough room. Hmm. That's wrong. Hold on. Trying to remember. Trying to remember exactly which way numbers go. And then this can go on like this. And of course we also need these enable pins to be active somehow. Which is going to require GPU logic to tell it whether or not to render the 0 or to just leave it blank like this. There's so many problems you encounter with machines like this, and the more complicated it is, the worse the problems become. This router is actually pretty similar to what I was planning on using for the memory banks, only different concept, and also only one direction, linear. This, I think, would actually allow for branches in the memory modules. And if I do it that way, technically the latency would be reduced dramatically. Actually, yes, this may actually be the way that I do it. And so, instead of them being in a line, firstly just getting rid of all of this. And I feel like now we need a lot more room. So I'm just going to extend to the floor. And so now the memory should look more like this. That's too close together. Technically that is too far as well. Yes. This already has potential, and then each one of these sub-branches can have their own set of branches. And because of how the router works, it can send and receive information from here to any one of 15 sub-branches, or perhaps 16 sub-branches. It's not immediately clear which one is correct. And so that's how the memory system should work now. This core is irrelevant. Yes. Starting to look much more rational and sane. I'm still not exactly sure how to do this part, and it's very important that I do it correctly, otherwise it's not going to be favorable. Hmm. Now this is probably the hardest part of the design process currently. Then I think the next hardest part, after assembling all of these parts and debugging, would need to be software design. Designing software for a machine like this. The first thing you would want to do is design a higher level language to program in. If you don't enjoy suffering, that is. I'm also thinking about, instead of having jump instructions, have built-in capabilities for functions and subroutines, so that you don't even need jump instructions. You would need to have a more advanced control logic system built into either the hardware or just how the hardware works. Oh yes, and with this type of memory, you can only write to one slot at a time. So this entire design may be critically flawed. Yeah. Yeah, most of what I'm doing now is just fretting the future. I should be wiring. Don't ask questions, just wire. That's one more column. And now I'm going to rotate the pattern so that I'm doing it in a different direction, just to make it more interesting temporarily. There. And now I just have a smaller square to think about. Yes, I know, the most entertaining thing that ever happened. There's only so many times I can make a joke about things being uninteresting until the joke itself becomes uninteresting. And then I need to make a very meta-referential joke to bring light to the situation. Like what I'm doing right now, in order to break the monotony. Or to have a very shallow attempt at breaking the monotony, when in reality, there is no escape. There's just wires. Wires everywhere. Yes, and if you think this is bad, thinking back to the time you saw that one, or if you watched the earlier series, thinking back to the time that I showed that 64-bit, 8-bit, technically it's 64-bit addressable 8-bit memory bank. That was even more nightmarish than this, by orders of magnitude actually. So be thankful I didn't record that. I didn't even enjoy doing it. Although, to be honest, I don't really enjoy doing this either. I just want it done. I don't want to do all of the wiring for it. Wait, what's the name? Eh. And now I can clamp this onto the rest of the machine. And get rid of this part in order to fit all of this now. And at this point, oh yes, now I remember. And I think this is actually superfluous now. Or redundant, I should say. Or both are technically correct. So for... So for pulling out, it's the blue one. Which means that the green one is for pushing in. Which means that's the one I'm going to need to put all of these in order to push the accumulator. That also means these are going to need to be routed into here. And similarly, the blue one, this one, needs to be routed to all of these ones here for the purpose of pulling back out of the stack. And of course, this should allow us to do very small operations very quickly. Especially if it doesn't require very much memory addressing. There. And so that should be done now. And I can just color these in. Even simpler than I thought it would be. So we need a way of reading memory to the accumulator, while at the same time pushing to the stack. So pushing this value down and then accepting a new value from memory at the same time, and also a way of writing something to memory, perhaps with or without pulling from the stack and replacing this. That's all more complicated though. At least we have the stack on now though. And what else? I very much prefer the more PCB-like design of this though. It's much easier to work with. And this is going to be a nightmare. I might as well just do it the way that I know how to do it right now, and then revise it later. However, there is one thing I can improve, and that's because all of these I know are going to be attached. I don't need this abstraction layer anymore. This is just here to keep the pins held low under the circumstance that they wouldn't be attached to anything and would then be giving false signals, which is not ideal, by the way. And I need 4 of them in order to attach all 4 bits of the half byte. of any one of the half bytes. And the way I'm going to put them on is first I'm going to attach the first layer, then wire it together, then attach the second layer, because wiring them with all the layers attached together would be a nightmare again. There, now I can just do this. Much simpler. I remember a time when I attached it and then I wired it, which was a mistake. Look at this solid grid of this solid three-dimensional grid of logic gates. Imagine all of the logic that's happening inside of this giant hypercube of logic gates. It requires very steady control in order to connect these without breaking anything. There, I'm pretty sure I didn't miss anything. And now finally, the fourth layer, which is also the last layer. So I think the plan is small components like these won't have a board under them, but the large ones will. Oh yeah, I forgot to remove the yellow color coding because it's not going to be the output anymore. I'm just going to remove the parts that are visible. The rest of the parts don't matter. Oh, that's incorrect wiring. Need to fix that immediately. There, done. Yeah. And it's about time as well. We now have a usable bank. And all of these are unabstracted, so they all need to have the same input from wherever that input would come from. And look at how massive this is, only to store 16 half bytes, which is 8 bytes of memory. There. The full RAM. Look at how much bigger this memory chunk is than the actual ALU itself. I'm still not sure how to use this control unit design. Need to step through it logically is why, I'm pretty sure. So, thinking about it, it needs to start by... well, it needs a program counter, actually, which is part of the machine's state, the internal state. My idea was to have a program counter that was built into memory so that you could count infinitely large. But I have a feeling it would be better if you just loaded the program in chunks from deeper memory instead of addressing the memory itself and then executing it at the same time. So I'm going to put this here instead. And so now I don't need to do all of that. Hmm. Hmm. Trying to think. Hmm. Perhaps I'm overthinking. Hmm. And so the program counter would start at 1. Oh yeah, guess what a program counter needs? The counter. Here we have one. And so this is easy to attach. Hmm. Here? No. Here. And it's at a slant. Not perfect, but should be good enough. Temporarily, I'm going to wire the output of the counter directly to the memory for it, which is not ideal for if you want to change it without using the counter, because the counter will be interfering. But right now it's fine, I'm sure. And of course, you want this to be held high. And then, yeah, actually if we attach the clock to this right now, we can see it in action. And that is actually functioning correctly, believe it or not. It's just doing it so quickly you can barely tell. Oh, I know how to make tunable clocks. What am I even doing? Hold on, I'm going to replace this entire clock right now. There, it's that simple. In fact, I'm going to make it inline to make it even better. And I'm going to reduce this to 12, because that feels appropriate in this instance. What else? No. This. I am going to keep this on its platform. And I'm going to put this, I'm going to clamp this directly on. And completely haphazardously. No regard for the future at all. There, and now I can visualize. Yes, this is correct. Yeah, I can only address 16 locations though. So I hope your program is only 16 instructions long in machine code. What is that? Probably under a single line of JavaScript or a C. There. Feels like very minor progress today, but it was actually a lot more than it looks.